Okay, so basically, good evening, everyone. This is going to be our fourth session on this chapter, that is Haloalkane and Haloarene. So let's just continue with this, okay? Yes, in the previous class, you assigned a question. Please answer this question, everyone. So this is a question basically, and try to answer this question. It's a very advanced question. Question ask about that if in this given molecule you are going to follow the Br2 addition, it means that is the bromine is going to add, okay? In the given monobromination reaction, the number of possible chiral product. Question ask about the number of possible chiral product. In short, you have to check it for that carbon which is combined with four different group once the bromine connected here, okay? So this is basically the question want to ask, okay? So yes, please. If you solve, please answer the question. Otherwise, I will explain this. Two, okay, Jam. Okay, one, Richard. Very good evening, Jatin. Okay, then, so let's find out the answer for this question. What does the question basically ask? That in this given compound, okay, what is given to us? This is the given compound. So in this given compound, if we were to undergo the monochlorination, let's say bromination, I'm sorry. So what is happening? First of all, see this is a CH2. Okay, this is further connected with some CH2, and this is a CH3, right? And this carbon, it's connected with the bromine, and this side we are having hydrogen, and basically this is CH3. So let's see the all possible choice. Maybe first of all bromine connected on this carbon. Okay, maybe the bromine connected on this carbon. So let's see what is going to happen there. That it will remain same CH2, CH2 and CH3. Okay, and again that bromine connected here and hydrogen connected here, and it means this carbon now connected with bromine. So yes, this is the possible product. But my question to you, is this chiral? Is this chiral? So let's check that it is connected with four different group or not. So let's observe this. Okay, no. If you have to observe here, already it's connected with two hydrogen. It means yes, it is possible, but it's not chiral. Okay, it is chiral. This center is not chiral. But see, question not ask about the chiral center. Question ask about the chiral product. Are you getting the meaning of this word chiral product there? So wait, if this center is not going to be the chiral, but observe this red one. Look at this. This is chiral. This is chiral. Okay, maybe you missed this point. Question not ask about like if you to connect the bromine and then it generated as a chiral. No. The in this case, still a chiral compound is present there, and this is the meaning simple here. It's a chiral compound. So yes, this is correct answer. Let's see one more possibility there. That let me just first check, is it visible? Okay, like this. So see, this is a chiral there. Let's move further. Let's see one more point here. Observe this. Sometimes it is irritating. Okay, so let's move again. Now let's discuss about that again. The second possibility is what? Maybe the given bromine connected on this center. Okay, maybe this upcoming bromine connected here, and it will remain CH3, and it is a CH2. It's a CH2 and it's a CH3. Okay, is this chiral or not? Is this given compound is chiral or not? Yes, please. It is. Is it chiral or not? No, right? If let's suppose you to observe this, yes, it's not right. So if you have to observe this carbon, two bromine connected, it's not chiral. Okay, so it means yes, it is possible, but not chiral. This is a product number two, which is a chiral or not chiral. So cross this. Third possibility, that maybe this side, this CH combined with CH2 and CH3, and maybe the bromine connected here. Okay, same, is this chiral? Yes, of course it is chiral. Okay, although the center is not chiral, but at least this carbon have to be chiral, right? So it's chiral. Chiral. Next possibility, that this carbon and it's C. Now the next, maybe this is connected with bromine, and this is CH3, okay? And this is further CH3 and bromine and hydrogen. So is it chiral? Yes, this is chiral one more time. One more, the last possibility, that this carbon is connected with CH2, CH2, and maybe the this bromine is connected here now. So question ask about basically the bromination, monobromination. Okay, we're not checking for mono or like di product here. So this is a simple case here. Okay, it's a CH3 and wait, this is connected with bromine. This is connected with bromine and this is hydrogen and this is CH3. So total how many product we are getting? Which one is chiral? Okay, any more possibility you can check. So total how many product we are getting generally? That is one, two, three, and four, right? Four here and one on the previous slide. Total five. But out of five product, only four is chiral one, right? Only four is the chiral one. So let's just back here. And what will be the correct answer for this question? That this is a compound number one, which is chiral. Okay, let me just erase all the numbers so that you are getting my point. Okay, this is a second product, and this is the third product, and this is the fourth. All are the chiral. Why this is chiral? Because again, the center is going to be the chiral. Okay, so that's it. This is all for the question, and the correct answer for this question is going to be the option, sorry, answer four. Four is the chiral possible product we're getting. Okay, that's it. So this is all for the previous class. Let's continue with the today's class. In today's class, we're going to discuss about the physical property. Okay, like physical property wise, how about the color and order? You know what is the meaning of physical property when you to observe something physically, like color, boiling point, solubility, and density. Okay, so it's like a repeated part. We just discuss like so color and order, colorless, orderless. Same here. Boiling point, as we know, the main point, boiling point is basically depend upon the molar mass or like surface area, and then solubility like the same funda like dissolve and like dissolve like, right? Polar, non-polar, polar, and non-polar, non-polar, right? And then density there. So these are the topic basically we are going to cover in today's class. So let's start with the very first point. It's going to be the color. Okay, so generally halo compound are colorless. It means there's a no color, there's a no color in their pure form. Okay, but bromide and iodide sometime they develop some color when they're exposed to the light. Okay, that iodine and bromine, yes, impart some color when you expose them into the light. Okay, this is all for the color, very simple. Let's continue further. Let's just talk about the order. So although that if we're checking for the like order here, so volatile halogens, not every halogen, only those halogen which is volatile in nature, they are having a very sweet smell there. Okay, generally they are orderless, but only the volatile halogen. I hope you know the meaning of volatile word. The thing which can easily evaporate as soon as that it came contact with the air or something. Volatile. Okay, that's it. Like that camphor. Okay, so it's a volatile there. Sweet smell we are having. Let's see that some important point. Now let's just talk about the boiling point. So before starting with the boiling point, let's just discuss about a very much important point in a boiling point. So how about the important point that let's just quickly recall the boiling point, that if we are to compare, boiling point is directly proportional to the surface area, right? Larger is the surface area, higher will be the boiling point. Okay, larger will be the surface area, that higher will be the boiling point. It is directly proportional to the molar mass. Obvious that higher is the molar mass, higher is the boiling point. And that of course the van der Waals forces of attraction there as well. Okay, you can say that forces of attraction. And here we're dealing with the van der Waals forces. So force of attraction, like stronger is the forces, weaker is the forces. So all these things decide the boiling point here. Okay, that's it. This is very simple. Now let's discuss some important point. For example, let's just compare the hydrocarbon. Okay, hydrocarbon with haloalkanes, or like let's say the haloarene as well. So hydrocarbon, according to you, has a maximum boiling point or minimum boiling point? Think about it. Like if you to compare the hydrocarbon, very good evening Pranita, hydrocarbon has a maximum boiling point or a minimum boiling point if you to compare with the haloalkane or haloalene or alkyl halide? What do you think about it? Lower, lower, less. Okay, answer is very simple because we know that the alkyl halide are polar in nature, right? So that's why obviously that they are having a higher boiling point, right? Okay, one more before discussing about this point. Be noted, boiling point is not like that we are breaking the bond. Boiling point means we are breaking the weak countable force of attraction. For example, if let's suppose I want to boil the water, it not like that if you have to boil this, it is converted into H positive in which I no, no, no. Actually, what we are doing there, if let's suppose this is my water molecule and it is forming basically the one like hydrogen bonding, and basically we're breaking these kind of bond there. So boiling point is very simple. We are breaking the weak van der Waals force of attraction between the molecule. Okay, so it's not like we are going to break the molecule. So let's discuss about some important the factor affecting the boiling point. Okay, so let's see the factor affecting the boiling point. So observe this, the that polarity in a size of a compound, since the stronger intermolecular force of attraction are present in a haloalkane because they are polar, right? And large amount of heat is required to break between the bond of the halogen. Why? For example, if you are having some Rx there, this one has a partial negative charge, this one has a partial positive charge. There is a one more halogen compound R positive next. This is partial positive, this is partial negative, and there is a force of attraction between this partial positive and partial negative. It is basically a polar bond. So it's a polar bond, and it is very difficult to break a polar bond as compared to the non-polar bond. Okay, that's it. This is a simple meaning of the word that boiling point here. Okay, so let's move further. Okay, so yes, let's continue. That what we are discussing here, that polarity. Okay, it's a request to everyone, please join on a time. Okay, okay. I'm sorry. Oh, I just forget about this. Okay, I hope it's now visible, right, Mayank? I'm sorry for this. So yeah, let's just continue. What we're discussing, that this is polar now, difficult to break there. Second one, that second one is what? Hence the boiling point also increases as the polarity or the size of the compound. As we just discussed, boiling point is directly proportional to the surface area in everything, right? Surface area, molecular mass, size, but plus polarity as well. Okay, for example, there is a question for you. Try to answer this question. This is a simple question. If let's suppose I'm having CH3, CH2 and CH3, this is the compound number 1, and the second one is what? CH3 and CH2 and chlorine. So can you just tell me between A and B, which one has a maximum boiling point? Is it A or is it B? A, B, A, B. Okay, but like in the first one there is a two carbon, sorry, three carbon, but in the second one there is a two carbon. Then why the option number B is the correct here? So answer is very simple, because we have to give the priority to the molar mass, right? Chlorine is like has a maximum molar mass as compared if you have to compare one CH3, because there's only 15 grams is the mass there, right? I hope this point is clear for everyone, right? Yeah, of course. So let's compare something. Observe this slide here, that in this slide what we are comparing, that we are simply comparing the point that if you to observe this is my C2H6 there. Okay, C2H6, it means a normal halo alkane there, sorry, normal hydrocarbon there, but if the same number of carbon like C2H6, okay, in the C2H6, if you to replace one hydrogen, that is C2H5 with some chlorine, okay, in the second one bromine, in the third one that is iodine. So what we are observing, if you are moving toward halogen, like all three cases has a maximum boiling point, right? As compared to the normal, this hydrocarbon there. But if you have to compare between this, like look at the Cl there, bromine there, and iodine. So in between all these 3 points, that now the topic of discussion is not the hydrocarbon, that chlorine, bromine, and iodine. If you are moving from chlorine to bromine to iodine, so mass start increasing there. Okay, so this is basically the simple point here. Okay then, so many comparison. Okay, maybe it's not visible for you. Let me just write what is it here. That in the first one we are having CH3Cl. Okay, in the second one we are having a CH3Br, and in the third one we are having a CH3I there. Okay, this and this. So CH3Cl, like same thing repeating again and again. If you are moving from there to there, so the graph start increasing. Okay, this side what we are comparing, this side we are comparing the number of carbon. For example, in this case, what is difference? The first of all, the CH3Cl, the second is what? That is CH3, CH2 and Cl. The third one is what? CH3, CH2 and CH2 and Cl there. It means if we are moving from there to there, from this to this graph, what is happening this time, that is the carbon number keep changing here, two carbon, sorry, one carbon, two carbon, and three carbon. That's it. This is all for this slide. Okay, now let's compare one more important point here, the last slide of the comparison of the boiling point. Observe this. In this case, what is it written there? This orange one is this chlorine, and this blue one is the bromine, and this yellow one is the iodine there. Okay, so in this case, if you have to observe this, that for this, like if you are using CH3X, if you are using CH3X, X can be chlorine, X can be bromine, or X can be iodine. All three present in gaseous state. Okay, now what does this written below 295? Okay, so my question to you, like, why the chlorine is a gas? First of all, answer this question, then this graph will be clear for everyone. My question, that why chlorine is a gas? Okay, so like, not polar, no, no, it's not like, but iodine is a solid. Then now has you. Okay. Okay, like, hint for you, temperature. Okay, temperature. You know, like, why something visible as to like a solid state, liquid state, and vapor state? Because we are observing something at a low room temperature, right? Maybe you have to observe the same chlorine at a lower temperature or a higher pressure. Recall, that is the liquefaction point. That if you have to compress some gas, it's at liquefaction. That is a which chapter? States of matter. We discuss in 11th class, right? So temperature vary. So what is the meaning of this point? That below 298 Kelvin, that all three thing has a temperature or the boiling point level lower than 298. It means below 25 degrees Celsius, right? So it represents simply that they are gases at a room temperature. Yes, very good, Sanjana. Okay, that's it. This is the highlighted point here on the slide. That's it. Okay, so yeah, all four are the that gases in nature. Further, that if you have to compare this, like, it's very simple. Like, if you're moving from chlorine to bromine to iodine, so basically it's increasing. Important is what? Why below 298 we are able to see that only the gaseous state. Okay, now let's solve some question. I guess you are ready, right? So let's try to solve some questions there. This is a question number one. Please answer this question. Chloromethane, bromomethane, dibromomethane, and bromoform. So according to you, like, what will be the order? Okay, very simple. Please answer this. Take some time and then answer the question. Okay, it's easy, but the problem with the easy question be like always the reason behind the negative marking, right? You have to solve this, please. Okay. Okay, there's so much variations in the answer, like what you are doing. Okay, let's see the correct answer here. Okay, so observe this. This is a chloromethane, right? It's a chloromethane. So we can write the chloromethane be like, it is going to be the CH3 and Cl. It's a bromomethane. It means that is a CH3 and Br there. And it is a dibromomethane, right? So in this case, technically we're getting a two time of the bromine. It's a CH2 and Br2. And it's a bromoform. What is the meaning of bromoform? Okay, maybe you don't know the formula for bromoform, but at least we know what is chloroform, right? That it's a very good anesthetic agent, that you know very well what is the use of chloroform. So this is chloroform, right? So what is the meaning of bromoform? That if you have to replace the chlorine with the bromine, so basically it is going to be the CH and Br3 there. So like, I just observe, like, you answer this like DCBA. So has you DCBA and Richard ADC and DCBA, and you said, Mayank, ascending order. So ascending order means, like, we are moving from lower to higher. Okay, you are right as well. Okay, so that's it. So basically you're right, but some of you, okay, please solve this properly. As I already told you, question is easy, but the problem is what solution there. So that's why this is a correct answer, because here you are having a three time of bromine. Okay, and in this case two time of bromine, one time of bromine, and yes, chlorine is lesser. Okay, so this is a correct order, that DCBA. Same, please answer the second question. Same, order of the boiling point, or arrange them increasing, decreasing, which one you like. Again, please solve properly, then answer the question, okay? Okay, there's a first question for you. What is the IUPAC name nomenclature for this iso propyl chloride? What is it really? 2-chloropropane, okay. 2-chloropropane. Okay, not bad. Okay, okay. And yes, everyone, most of the you are correct. But can you justify your answer, like why C first? What is the reason behind this? Okay, Mike. Mike is very smart. Okay, no need to arrange them. Just ascending, descending. Ma'am, you have to decide what is ascending, what is descending. Right? More number of carbon. No. Very good, Sanjana. Okay, what is really happening there? That first of all, yeah, you can say basically you're half and half right. That in between this and this, the answer is very just because of the carbon there. But isopropyl chloride, it's one more point here that is a branching. That if you to compare between A and B, the reason behind this is what branching only. So I guess everyone you already know what is the meaning of iso and neo. If you don't know, let me just quickly brief you. What is iso point here? That you have to check it for this kind of point. Why? Okay. So if something this kind of part we are getting, so it is known as a ISO. It is known as a ISO. As the question asked about isopropyl, right? Isopropyl. So let's just handle it chlorine later. First of all, isopropyl. It means you can say three carbon. So one carbon, two carbon, three carbon. We want this Y structure for the iso, right? So that one carbon, two carbon, three carbon, and one more chlorine connected here. So let me just connect CH3 here, CH3 here, and this is my CH. Okay, and chlorine there. And the second one is given to us, that is one chloropropane. Oh, it's white color. Okay, so second one is given, that is one chloropropane. So what is the meaning of one chloropropane? It's simple. That is one carbon, two carbon, three carbon, and chlorine is correct connected here. So if yeah, that I just ask you about, that is the IUPAC nomenclature for this isopropyl word. So what will be that? Let's just see. So let's give the numbering one, two, and like three there. So here the second position the chlorine there. So you can say two chloro and propane. 2-chloropropane. So remember that branching is inversely proportional to the boiling point. It's really very important point there that more is the branching, lesser will be the surface area. So boiling point is inversely proportional to the branching. So reason is very simple because it reduces the surface area. Okay, so you can say it reduces the surface area. That's why we are going to follow that first of all straight chain, then branching. Okay, so reduce the surface area there. So let's just back here. The second question. Okay, yes, here. So observe this. This is a isopropyl chloride. Less between this and this, and this is very simple because here we are having a four carbon because it is a like chlorobutane there. So one carbon, two carbon, three carbon, four carbon, and then chlorine connected here. Okay, maybe it is not visible for you. Let me just write here. So it's a one carbon, two carbon, three carbon, four carbon, and chlorine connected here. And just connect the hydrogen be like this. This is my CH2, CH2, and CH3. So answer is very simple. It means the C is maximum, then B, and then A. So very good, everyone. Like most of you give the correct answer already. Okay, let's see more questions. Second, I not second, third and fourth question. Yes, please. Same question. Boiling point. Boiling point order. Yes, please. DCBA. Okay, man. DC. Okay. Was right, was wrong. Some student has a problem with this arrow, I guess, sometime, right? Like maximum or minimum which side. Because it's really easy. Hmm. Actually, see, Hazu, what is the problem? I just arrange them like that way so that we can easily solve them, okay? But I am sorry, like it's my problem. Two answer is already given. I'm sorry for this. So anyway, let's see the correct answer for this question. That it's iodoethane and then bromoethane and then chloroethane. Answer is simple because it's a ethane, it's a ethane, it's a ethane, ethane, right? So what is the common here? This is iodine, this is the bromine, this is the chlorine, and this is the fluorine. Okay, so it's already given, right? Okay, then this is all for the boiling point and all these things. Okay, now next question for you. What do you think about melting point? What do you think about melting points? Melting point is also depend upon the surface area or not? Yes, please. Okay, there's a question for you. Okay, let's just check you really know the concept or not. Okay, for this question, you have to answer the melting point. Okay, my question to you that arrange them in the melting point order. Okay, so question melting point you have to identify. Okay, so it is CH3, CH3. Option number one. It is a CH3. And yes, please answer the question which one has a maximum melting point? Because you said that both are same, right? Hmm, just do this. A or B. Which one has a maximum melting point? You know that in the very first chapter, if you remember that solid state, we discuss about a point symmetry, right? Symmetry. So, okay, technically you're right, Hazio, but then why the option number B is the correct here? Because if you have to go with the yes, that is a chakshu, you're right there. That option number is going to be the correct. Because just think about it. That let's see that first of all, we are having this right. So let's arrange them. There's a so many molecules, so it's completely arranged like this. Okay. So what is it? It is symmetrical arrangement there. Okay, it is a symmetrical arrangement simply. But on the other hand, if let's suppose I want to join this, observe this, that maybe this is the molecule. Okay, maybe the second molecule is not like that. Maybe the second molecule is like this. Okay, because you know there's a random arrangement in the given sample there. Okay, but trans you can revert that. It's not an issue for you. So be noted that melting point is basically decided by the symmetry. So it is not like the boiling point. Yes, we can say that it is directly proportional to the like surface area and all these things, but still it is depend upon the symmetry. Symmetry play a very much important role here. Yes, Asio. Okay, although your explanation is right, but question is answer is wrong, right? So melting point is directly proportional to the symmetrical arrangement. Okay, or you can say symmetry there. Symmetry is the important point here. Okay, so symmetry play an important role there. That's it. This is all for the case. So okay, let's continue further. We are discussing about the melting point, right? So yes, let's observe this point that boiling and melting point of a haloarene. So first of all, that boiling point is very chill. Like boiling point generally depend upon of isomeric that dihalobromine are nearly the same there. It means this slide want to explain simple one word to you that if let's suppose okay, this is a kind of important point. If let's suppose I'm having one chlorine and chlorine, okay, option number one, and this is the second one. Look at this chlorine and chlorine. I'm sorry, like meta to one another, chlorine, and okay, it's a B and it's a C, last one. So, first question, can you just tell me the sorry, boiling point first of all? A, B, and C. According to you, which one has a maximum boiling point? C. But why C? No. Okay, see, recall what is boiling point? Boiling point depend upon the, you can say, the area. Okay, or branching. Oh, no, 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 Hasio. You are just like mixing the concept. It's a boiling point. It's a boiling point. Boiling point not depend upon the symmetry. Boiling point be like number of carbon. Boiling point be like that branching or not. So both are the chlorine, both are the chlorine, both are the chlorine. So branching is not an issue there. So what does this first line state there? That boiling point of all the three compound is same. Okay, I'm not saying same, but let's say similar, almost similar. It is almost similar. So it's written there that the boiling point of the isomeric dibenzene are nearly the same. But second point, observe this, that if you to go with the melting point there, so melting point of the molecule with a better packing in the solid have a maximum melting point. Okay, now the same question, that what do you think about the melting point? So boiling point is same, but melting point wise, which one is more symmetrical? Para. Yes, very good, Richard. So now the correct answer for this question is going to be the para one. So why? Because observe this, that perfect symmetrical structure. Okay, same thing like this side, same thing like this side. Okay, so that's why this is more symmetrical structure, and hence it is going to be the correct answer here. Okay, so that's it. Okay, next one is solubility. This is the last topic. Okay, yes, solubility. So before starting with this word solubility, my first question to you, what do you think about the solubility of haloalkane, or you can say haloarene, that alkyl halide? Okay, this is a question for you. Question: alkyl halide more soluble, alkyl halide more soluble in water or organic solvent? What do you think about it? Yes, please. Okay, Mayank. What do you think? Like, this question is that much easy. Organic, I think. Then why? Why you think about it? Like organic is the correct answer? Because the normal people answer the question, be like, ma'am, more soluble in water. Because like this all like, right? Okay. So like there's just so many organic compound which is soluble in water, right? We discussed so many time polar, non-polar, right? Hydrogen bonding. So what? Okay. No, like your concept is not very good because right now we know polar like dissolve like and non-polar dissolve and non-polar. Right? So question is very simple, that alkyl halide is polar. Okay? Water is polar. And organic compound is non-polar. So according to the logic, that this alkyl halide is soluble in which more? Water or what? This is question basically. Okay, there's a race. Okay, listen, my point first of all, do you know it's a very much important point here. Although this is a polar, but still it is more soluble. It is more soluble in organic solvent. I will tell you why. Although this is polar, water is polar, logic said that it will be more soluble in water, but why it is more soluble in organic solvent? This is the important question now. Okay, so let's try to understand the complete mechanism behind this. Okay, so think about it. There is a two container number one, in this you are having a water, and let's add alkali. Let me just use rx, right? Rx there. So as we just discussed, that rx is some bond, obviously, because it's a polar bond there, right? So it's a negative. Okay, it's a positive, it's a positive there. So let me just revert this. Let's just see, this is rnx. Okay, rnx. So basically there is a some bond between them, and if you to observe the water, so still in water that hydrogen bonding is present, we discussed so many time, right, already. So this is the forces there. Okay, so listen, that what is really happening, if you recall the complete solution unit, first of all this rx bond is going to break, right? And then water is also present there. Remember, quickly recall NaCl. If you have to add the NaCl to the water, first of all you have to break the NaCl, then water molecule bond break, and then Na positive generated, then water surround the Na, be like, remember. So what is happening basically, first of all you have to break the like alkyl halide, then you have to break the bond between the water, and then the third point is what, that water surround the halogens. So let's just see that it is breaking now, and let's say we are getting R has a positive charge, or water molecules around like this, because we know it's a partial negative charge. So first of all, it is what, bond breaking. It is a bond breaking. Okay, same bond breaking. And if you to observe this last point, it is a bond formation. Okay, it is a bond formation. Now, can you just tell me when the energy released? Bond formation or bond breaking? Yes, please. when the energy release, bond formation or bond yes, bond formation. It's a very simple, it's a very basic answer of the chemical bond. We know when bond form, energy that release, because you know why the bond formation take place, in order to get the stability. How to get the stability? By releasing the energy. Okay, then, so release energy, right? Okay, so observe this. In this case, how much of energy release? Let's say in this case, that energy released, you can say minus 100 energy released. Okay, I hope you know the meaning of energy release, so it's going to be the negative. And in this case, the energy required. Okay, in this above case, the energy required there. So observe this. In this case, we are requiring the energy. So let's suppose the required energy is plus 200. Okay, so you want to go with this deal or not? Energy required plus 200, energy is only 100. So is it okay or not? Okay, obviously we are not going to supply any extra amount of energy from outside, right? You know actually how the bond formation dissolve happening there, energy release, energy consume, and then they start dissolving there. So hello alkane or hello erin be like, no, we can't dissolve in water because there is so much amount of energy required. Okay, then let's observe the second point. If you have to go with the second one, that is organic solvent there, same haloalkane or same haloarene form, that their opposite case have to be there. Let me just explain the second scenario, what is going to happen there. But on the other hand, if let's suppose I'm having a water, okay, sorry, organic solvent, it is a organic solvent. So in this time, what is happening there, this is my organic solvent and this is alkyl halide. So same here, if in both the cases you have to break the bond, okay, break bond, so you can say break bonding there. So it is required, let's say plus 200 energy, but this time that rx bond with the organic solvent require that release, let's say minus 300 energy there. So what is happening, that this time our release energy is more than the required one, and yes, it's a great deal, and yes, molecule going to follow this. So what is the explanation for this point here? Simply, let me just move toward the theory part. Now let's try to read this point here. How about the solubility case here? Oh, not the slide. Solubility. Yes, here. Filling point. Solubility, yes. So observe this. What is written here? Hence, haloalkane are slightly soluble in water. Why it's written slightly soluble? Because answer is very simple. That energy required. Okay. This is the comparison that in organic solvent, here the energy required to break the bond between Rx and the bond between the organic solvent is, observe this, approximate same, nearly same. We can bear that energy released when a new bond form. So what does this slide really want to explain to us? That if you have to break a bond between Rx and organic solvent, so the energy required, okay, the energy required is almost same is equal to the energy released. Okay, so it's very important question, it's very important question of the organic chemistry. Because every time what we think like, okay, energy that polar dissolve in polar, but this is the only case where polar dissolve in non-polar, because the problem with the energy. Okay, this is very much important point of this chapter. Okay, solubility point here. Okay, any problem with this, please let me know, because my PC battery is about to die. Okay, so let's see the last topic, density of the haloid compound. Okay, please let me know if there is any problem. Okay, please feel free to ask. Let's see the last topic of the class, density there. So how about the density? We know density depend upon 2 point, that is in density increase with increase in the carbon and hydrogen. Obviously, let's suppose if you to observe, this is my CH4 methane, and this is my CH3 and CH2 and CH3. So obviously more is the number of carbon, more will be the density there. And same here, that increase in the atomic mass. So 2 point play a very much important role, the number of carbon or the number of carbon and like halogen as well. So let's observe let's see the comparison between them. So if you have to observe, this is NCH3, CH2 and Cl. And in this case, CH3 and 7 bromine. You know what is happening there? The carbon is same, C3, it's 7 chlorine, and this is bromine, this is iodine. So same, if you're moving from there to there, density keep increasing. So it's very simple. Like the melting and boiling point, that density also depend upon the number of carbon and the halogen as well. Okay, let's see a question. Please answer this question. Which of the following statement is correct? Okay, last question of the class. Which statement is correct here? All of the above. Okay. Okay, Sanjana. Okay, Diksha. It's not like all of is there, so maybe that is the correct answer, okay? Maybe it's not the case. C, D, okay. Okay, so much variations. So let's read these point one by one. Okay, just let's find out the answer. It is correct or not. First of all, boiling point of the isomeric dihalo benzene are almost same. Yes, we just discuss. You can take para, you can take meta, you can take ortho as well. All three has almost same. So it is correct, right? Second statement, melting point of the para is more over the ortho and meta. Obviously, we just discuss symmetry there. Remember that if both the thing present at para, so they're perfectly in a symmetry. C option said that haloalkane are soluble in organic solvent, but they are slightly soluble in water. Yes, we just discussed about this. That haloalkane is the only case which is more soluble. Everything we discuss, right? Wait. Okay, please. Wait, okay. Okay, I would to plug my laptop. Just wait, okay? Okay, wait. Okay, you are able to hear me? Okay. Actually, my screen is not working right now. Okay. So yes, that what is the correct answer for this question? Okay, that is option number D. If you are able to hear me, so maybe abruptly the PC will be switch off. Okay. So yes, please be noted. Option number D is going to be the correct here. Okay. Wait. Okay. Okay, it's working fine now. Okay, I'm sorry for this. Like, okay, let's back again. No, no. Okay, actually, see, I'm not able to do anything, okay? So that's why I'm sorry. So let's continue next time to make sure this. So yeah, what we're discussing, option number D is going to be the correct, okay? So it's very simple question for you. Option D is the correct here. Now, a common sense question for you, okay? That's it. This is all for the class. It will be a question for you. It's not like related with this chapter. It is a part of the GUC chapter, okay? So that we can revise some topic from the previous classes as well, okay? First of all, this is all for the today's class. Okay, but wait everyone, I'm not going to end the class. Last question for you, okay? And it's an advanced question, okay? Now answer please. If the given thing, okay, wait. Okay, let's go. Let me just switch OCS3 here. If we undergo the hallucination, anything you can take chlorine or FPR. Yes. So which position is visible? Ortho. Okay, let me just write some symbols. It is option number A, it is option number B, it is option number C, or it is D. Which position you to prefer and why? Yes, of course, Diksha. Let's just first solve this question, then I will let you know, okay? Wait for a while, please. Okay, it's a B. It's a B. B. A, C, D. Which position you have to prefer? This is my question. B, B, D. Okay. So yes, both are the plus M group, right? This is plus M, plus H you can say. You can say ortho and para-directing. And this is my plus M group. This is also ortho and para-directing. So how to decide which according to which you to like decide the position? Is it OH OCH3 or is it like this CH3? Which one you to prefer? No. What does the rule said? If you are having both ortho and para-directing one, so the stronger one is the deciding factor. No, plus M is the dominating one. No, Hasio. We discussed, right? A Harry rule. Remember or not? That is the mesomeric effect is the dominating over the hyperconjugation is dominating over the inductive factor. And obvious the oxygen has a lone pair. It is the more dominating one. Okay. So this one is the deciding factor. Okay. First point is clear for everyone how to decide with respect to the stronger one, stronger activating group. Okay. So let's move further. No, no, I said plus H. Okay, I'm sorry. It is visible like M, but it's a plus H. I'm not saying it's a plus M. Okay, I said it's a plus H. Plus H plus M both are the deciding factor for the ortho and parallel direction. Okay, has you? So yeah, it means remove this. It is not the deciding factor. No. Let me just erase this. Okay. So with respect to this, ortho and para, right? So ortho position. This is ortho position. This is ortho position or this is para position. So just by using this option, we are able to remove option number C. Now A, B and D. Which one is the more preferable one? Okay, if you have to observe this, if let's suppose we have to go with the B, remember the rule that all three group in a sequence. Observe this CH3, observe this cellulose, observe this OCH3. All three group in a sequence is so much hindered. It's really so much hindered there. Okay, so that's why we can't go with the B because it is not feasible. Okay, it is not visible. So let me just remove this. It means this position is also not visible. Okay, not visible. Now compare between B and D. So now which one you to prefer, A or B? Okay, so now the last point. Okay, after the conclusion, after deciding every point, now the next point is going to be the observe this. If electrophile come here, okay, this is electrophile here. Electrophile try to approach here, and the D case that electrophile approaches here. So D be like, okay, you know what is it? Although this is a plus M group, but it is a minus I group as well. And although this is a plus H, but this is plus I as well. Okay, so if electrophile come here, so CH3 be like, I'm a plus I, okay? I will increase the electron density, just come here. But on the other hand, yes, after deciding all the thing, OCH3 be like, remember we discussed this thing so many times that if some group is connected here, so at that position, inductive effect is the dominating. Here I only, right here both are the dominating and here M only. We cover all these thing in a GUC part if you remember, right? So it's a circle, I'm sorry. Okay, so that's why what is the feasible position for this one? That is option number A, not the option number D. Okay, so just remove this and the incoming halogen is going to connect it at this position only. Okay, this position, and that's it. This is all for the question. Okay then, that's done. I hope this point is clear for everyone. So let's end the class. Thank you so much everyone for joining the class and okay, have a nice day. Thank you so much. And sorry for the technical problem. I'm sorry.